Hello students, welcome to the class of Digital Signal Processing. We were studying Z transform and we have discussed what is Z transform. We have done certain numerical problems on Z transform. We discussed about the region of convergence. Now today we are going to start with the properties of Z transform. We will be dealing with the linearity, time shifting and time reversal property in our first lecture on the properties of Z transform. And consequently, we will be dealing with all the properties. With the properties, we will be solving one example. And let's go on. So let's get started. Okay. So the first property that comes is the linearity property. What does this say? Is that if you have two signals whose Z transform you know, say I have two discrete time signals, x1n and x2n, and the respective Z transform. So first let me write over here the linearity property of Z transform. So this is your linearity property. Okay. Linearity property of Z transform. What we have to understand over here is that if you have two signals, x1n and x2n, the respective Z transform of these two you know, that is for the x1n if it is x1z, and for the x2n if you have x2z. If then in that case, if you are asked to take out the Z transform of the combination of these two signal, weighted combination. What does it mean by saying weighted combination is that the signals are multiplied by some constants. So suppose you have A into x1n plus B into x2n. And the Z transform of this will be, you have to find out the Z transform of this one. Then it is going to be the summation of the respective Z transform along with this weighted constants multiplied. So it will be A into x1z plus A into x2z, B into x2z. Let's go on and first try to prove this part. So any type of proving of the Z transform, any property of Z transform, then when you're going to prove it, that time you need to start with the definition of the Z transform. So what we need to prove is that the Z transform of A into x1n plus B into x2n should be A into x2z plus B into x2z. So this is my signal right now. According to the property or according to the formula of Z transform, or you can say the definition of Z transform, it's like n is varying from minus infinity to infinity. The signal you're taking inside this, the whole signal now is for us A into x1n plus B into x2n, right? A into x1n plus B into x2n. Put it inside the bracket and then write over here z to the power minus n. Fine. After this, separate it. Separate it means you will just separate the summation into n is equals to minus infinity to infinity a into x1n z to the power minus n plus n equals to minus infinity to infinity b into x2n into z to the power minus n. Now this A and B you can take out of the summation. So you can take it out, these A and B out of the summation. So what you can write is A, n equals to minus infinity to infinity, x1n into z to the power minus n, plus B, n is equals to minus infinity to infinity, x2n, z to the power minus n. So this is going to be, this is the Z transform of x1z. So we will write it x1z and B x2z. So this is how it is proved. Now let's do an example on this. Let's take the two signals, the two basic signals, so that you know about these signals once more. We will take the delta signal or the unit impulse signal plus the unit step signal. So you have to take out the Z transform of this signal. So they are combined in the linear format, right? So the individual Z transform of this one and this one should be added. Let's do it. First, we will try to take out the Z transform of delta n, and then we will find out the Z transform of un. So for us, the first signal, let us take this one as x1n, and this is my x2n. So when I'm taking the Z transform of x1n, I should write n is equals to minus infinity to infinity delta n z to the power minus n. Now delta n is an impulse signal. What is meant by an impulse signal in the discrete time domain is that the value of this signal is 1 at 0 and 0 elsewhere. So for the discrete time case, delta n is equals to 1 for n is equal to 0 and elsewhere, everywhere else it is 0. So the summation here will have no use because the signal exists for only one value, that is n is equals to 0. So what we are going to do is we will put the value n equals to 0. So what will this give us is the delta of 0 is 1 and z to the power minus 0 is 1. So this is going to give us 1. So the Z transform of delta n is 1. The Z transform of delta n is equal to 1. Now let us go to the other side and find out the Z transform of un. For finding out the Z transform of un, again, we will follow the same procedure. N is equals to minus infinity to infinity, u of n, z to the power minus n. U of n is a unit step sequence which will start from 0. The 0, it will have everywhere the value is going to be 1 and it will be in discrete time case because it's n over here. So 0, 1 depends upon the sampling period. We have already discussed all those things. So if it is the sampling period is 1, so at 0, then at 1, then at 2, this way the things will go on. So here it exists for n greater than equal to 0. Now, if you see over here, before 0, the value is 0. So the summation won't have any value before 0. So what we are going to do is we will change this summation from n equals to 0 to infinity. The value is how much? The value of un is 1. So 1 into z to the power minus n. If you see this, it is a geometric sequence. If you put z to the power minus n, that n equals to 0, the first will be 1, then z to the power minus 1, z to the power minus 2. This way it is going to go on. So the first term over here, this is your first term, and the common ratio is z to the power minus 1. You can divide second term by third term also, third term by second term also and check. Z to the power minus 2 divided by z to the power minus 1. In that case also the common ratio is z to the power minus 1. That's the meaning of common ratio, right? Whenever you divide two consecutive terms, then the ratio is same. That is your common ratio. So the summation of the geometric series, infinite geometric series, is given by a by 1 minus r. So we have already discussed this on the numericals, several numericals which we did. So now the answer is going to be a by 1 minus r. A is 1, 1 by 1 minus z to the power minus 1. If you write it very in a very clean way, then 1 by 1 minus 1 by z. That will give you z by z minus 1. So z to the power minus 1 is less than 1. What does that give? 1 by z is lesser than 1. That will give you mod z greater than 1. So the ROC is going to be mod z greater than 1. So this is, suppose, your unit circle. Okay, so this is going to be your ROC outside this unit circle. And for this, the ROC is all entire Z plane. Entire Z plane for delta n. And for this one, the ROC is this one. So the final ROC is going to be the intersection of these two. That is, the final ROC will only be the outside of the Z equals to 1 unit circle. So this is going to be your final ROC. Intersection, right? So this is going to be the final ROC, outside of the unit circle. जो unit circle हमने बनाया उसके बाहर का. Okay. So now let's move on to the next property. The next property is the time shifting property of the Z transform. Time shifting property of the Z transform. Now this time shifting property, what does it say is that if the Z transform of X of n is X of Z, then the Z transform of X of n minus m, or you can take any other variable also. Let's take n minus n naught, will be Z to the power minus n naught X of Z. Let's go for the proof of this. So what is your signal right now? Actually, it is X of n minus n naught. So n is equals to minus infinity to infinity. X of n minus n naught Z to the power minus n. Now you have to keep this as one new variable p. So let us take p equals to n minus n naught. So the Z transform, the summation over here is n will be x is from n minus n naught. That will be you will be putting over here p Z to the power minus. If you see over here, n will be equal to p plus n naught, right? P plus n naught. So the variable over here is changing to p. So here we are going to write p is equals to minus infinity to infinity. Now just see over here. You can break the exponent over there, that is z to the power minus of p plus n naught, into two parts. You can write it as z to the power minus p into z to the power minus n naught. So since this is not varying, n naught is not varying, only p is varying. So you can take it out of the summation. You can write over here z to the power minus n naught. P is equals to minus infinity to infinity. X of p, z to the power minus p. So this is now the Z transform. So we can write it simply z to the power minus n naught into x of z. This is how it is proved. Okay, now let's do a question on this one. And what will be the ROC? ROC will be the same as that of the previous one. Okay, now let's do a question on this. So the question given over here is x of n is equals to a to the power n minus 1, a to the power n minus 1, u of n minus 1. So for this discrete time signal, if you see, this is a shifted version of what? It originally, the signal would have been a to the power n un, and now you are shifting it by 1. That's why this has come. Now, what does it mean by shifting? They have done the proving and all everything. So let's first understand what is the meaning of proving. What is the meaning of shifting? Sorry. So if you take un, the signal is starting from 0, 1, 2, 3, 4. All the place the value is 1 for unit step sequence. Now, if I shift it by 1 unit to the right, then it is going to start from 1. At 0, it won't start. The value becomes 0 at 0 because the signal gets shifted towards the right. The signal is getting shifted towards the right. This is u of n minus 1. In the same way, if you take u of n plus 1, the signal is getting shifted towards the left by 1 unit. So it started from 0 over here. Now it will start from minus 1. So minus 1, 0, 1, 2, and 3. This will be there as the signal gets shifted by 1 unit to the left. Actually, this process is u of n minus minus 1. That's why shifted towards the left, and this is u of n minus plus 1. That's why shifted towards the right. So just remember the opposite of this sign. No need to keep all these things in mind. Just remember that you should know the actual thing behind it. But for doing the questions, you can keep in mind that it is shifting by 1 unit towards the right when there is a minus sign, and 1 unit towards the left if it is the plus sign. The number of units depend upon the value over here. If it is 2, it will be shifted by 2. Okay. So for this signal, if going by the property, if you try to find out the Z transform by using the property says that whatever will be the Z transform of this parent signal, you can take it as a parent signal. From this only this one is coming. Okay. So if you know the Z transform of this one, then you just need to multiply Z to the power minus 1 to the Z transform of this signal. Because what does the property say? If it is x of n minus n naught, if you want to find out the Z transform of x of n minus n naught, it will be equal to z to the power minus n naught x of z. And this x of z is for x of n, original signal x of n. So if this one is my original signal over here, a to the power n un, so can we find out the Z transform of this one? We have already done it in the numerical, so we can directly write the answer, but for your convenience, I will do it once again. Now see, I'm not writing here minus infinity to infinity because it is multiplied by un. Once any signal is multiplied by un, now that signal is going to always start from n equals to 0. So a to the power n, z to the power minus n. Now after this, what we are going to do is we will take inside together a into z to the power minus 1 whole raised to the power of n is equals to 0 to infinity. After this, the first term for us, when you put a 0 over here, that a into z to the power minus 1 whole raised to the power 0 will give you 1. 1 by 1 minus a z to the power minus 1. We have already done this. See, first term will be 1, second term this one, the third term will be this one. This way it will go on. So it is again a geometric sequence. If you divide the two consecutive terms, then you will get the common ratio as this one. Now, what is your ROC for this? A z to the power minus 1 is lesser than 1. That will give you mod A is lesser than mod Z. That means the ROC is going to be mod Z greater than A. But this is x of z. 1 by 1 minus a z inverse. Now to find the x of z for the signal, for this signal, that is an minus 1, un minus 1, a raised to the power n minus 1. So we had to find out a raised to the power n minus 1, u of n minus 1. So it is getting shifted by how many units? 1 unit. So the z transform for this, will be z to the power minus 1, 1 minus a z to the power minus 1. And the ROC is going to remain the same. This is your ROC. So just you need to multiply with z to the power minus of the shifted version. Here it was shifted by 1 unit, so we have multiplied it with minus 1. You can write it in a better way, like it can say 1 by z, 1 minus a by z. So this is going to give you how much? 1 by z, 1 by z, z minus a by z. That will give you z and z gets cancelled. So you will be getting 1 by z minus a. So this is going to be the z transform of a to the power n minus 1, u of n minus 1. So these are the two properties. We will be discussing the other properties in the next class. Thank you.